Hello developers. Welcome back to AnbuZ HobbieZ. Today, we're diving into the world of design patterns with a focus on the strategy design pattern in Java. If you've ever needed a way to define a family of algorithms, encapsulate each one, and make them interchangeable, you're in for a treat. Stick around as we explore the basics, showcase a real-world problem this pattern solves, break down the UML diagram, provide a hands-on code example, discuss its advantages, highlight common pitfalls, and wrap up with a solid conclusion. Imagine you have a class that performs a certain operation, and you want the flexibility to switch between different algorithms dynamically. You don't want to modify the class every time a new algorithm is introduced, and you want to avoid a monolithic codebase. This is where the strategy design pattern steps in, providing a clean and flexible way to encapsulate algorithms and make them interchangeable. The strategy pattern involves three main components: the context, the strategy interface, and concrete strategies. The context class maintains a reference to a strategy interface and delegates the algorithm execution to it. Concrete strategies are implementations of the strategy interface, encapsulating specific algorithms. This separation allows you to change algorithms at runtime without modifying the context class. Let's dive into some code. I have a Java project set up, and we'll implement the strategy design pattern to demonstrate how algorithms can be encapsulated and switched dynamically. I'll guide you through each step, and by the end, you'll have a practical understanding of how to use the strategy pattern in your own projects. In this example, we'll create a payment context class that allows switching between different payment strategies dynamically. Payment strategy is the strategy interface. Credit card payment and PayPal payment are concrete strategy classes. Payment context is the context class that uses a payment strategy dynamically. When the payment context processes a payment, it delegates the payment operation to the currently set payment strategy. This allows for easy switching between different payment strategies without modifying the context class. Now, let's talk about the advantages of using the strategy pattern. 1. Flexible algorithm selection. You can easily switch between algorithms at runtime, providing flexibility and adaptability. 2. Clean code. Algorithms are encapsulated in separate classes, promoting a clean and modular codebase. 3. Easy to extend. Adding new algorithms is straightforward and doesn't require modifications to existing code. However, it's important to be aware of potential pitfalls. 1. Overhead. In small projects or simple algorithms, the overhead of implementing the strategy pattern might outweigh its benefits. 2. Complexity. Introducing too many strategies and contexts without a clear separation of concerns can lead to unnecessary complexity. And there you have it, a deep dive into the strategy design pattern in Java. We've covered the basics, walked through a real-world example, discussed its advantages, and highlighted common pitfalls. Whether you're optimizing algorithms, implementing sorting strategies, or tackling any scenario that demands flexibility, the strategy pattern is a powerful tool. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more design pattern insights and Java tutorials. Happy coding, and I'll catch you in the next one.